Hello and welcome everybody. I am Kim Fletcher and I'm one of the organizers of the Virtual Java User Group. Thank you all for joining today and let us know in the chat where you are joining from. If you haven't already, please do join the Slack community. This is the best way to get your questions answered after the live stream and to connect with our speakers and fellow community members. Now, over to our host and our amazing speaker, the ones you've been waiting to see all month. And here they are.
Hi, hello. Thank you, Kim. Thank you very much for giving us the space and supporting us tonight. I'm Michelle Reese, and I'm going to be your host today. And I have the delight to present one of my best speakers. Well, I love how you present. You are always very educational, so I love listening and sitting down in your presentations. Venkat, but please introduce yourself. I will never make you justice.
Well, thank you, Ikshal, and I thank the members of the VJAG for the organization and everyone who took the time to join us as well. Really appreciate it. My name is Venkat Subramaniam. I just love programming, and I'm here to talk about programming. That's enough said. Let's get started.
I want to remind everybody, please pose your questions and we will try to answer. Well, Venkat will try to answer them and I will pose them to him as soon as we see them, or you can also wait at the end. And I have the first question, and that's my privilege. So, Venkat, this ain't your parents' Java. What make you create this session?
Excel, this is just absolutely fascinating to me to think about it. Do you know of a language? Well, do you know of a good language that has stayed popular, effective, and delivered year after year for close to 3 decades? 30 years is 2 generations combined. And when I started, and I'm sure a lot of us started programming in Java, it was a very different language. And now we have children or the next generation, which is using the same language that we once, saw being introduced. And to emphasize it, it's not the language I saw as a young developer. It's not your parents' Java. It's a very different language today. And I've heard this quite a few times from people saying, look at how different Java is today. I'm jealous of how different Java is today because I didn't get to use these things when I was a young programmer. That's what prompted me to give this title for the talk. This is not your parents' Java. It's for the next generation. That's what the language is for. And it's built for the next generation, I think.
Oh, well, I'm indeed very surprised and very excited about all the things that have come out in this 30 years, as you said. And I was reading some reports about the state of Java. And for example, the JetBrains, Buddy, New Relic have a really interesting statistics about how we're using Java or what version are we using. And we're still using a lot of 8. Hopefully, well, no, it's very interesting that we also have joined into Java 11 and 17, but we are not picking that as fast as we would like to. So I urge our audience to tell us what version of Java are you using as a developer? What is the version that you're trying? What is the version that you're using in production? And if you are thinking about moving, when would that be? In the meantime, I want to ask Venkat, what makes you excited? So since Java 8 towards Java 23 that we are having right now in our hands?
I'm like a kid in a candy store. That's unfair question in my opinion, because there are so many features in there that I'm really excited. But just for picking one, I'll tell you my most recent favorite, and there have been several, like I mentioned, but my most recent favorite is the feature of gatherers, the ability for us to extend the functional API, the pipeline, the functional pipeline to be able to create custom steps, intermediate steps in the functional pipeline gatherers are things that has kept me really excited.
Well, we were talking before this recording started, and we were talking about like how powerful they are, and with power comes responsibility and complexity. So I think that you will have more, and our audience is going to have more than enough questions and hopefully ideas in how to use them. But I want you to show us the features that you have prepared in your story about why this new Java is not how you and I started with Java.
Absolutely. And just to remind everyone, as you mentioned earlier, the best time to ask questions is anytime you have a question or a comment. And Excel, thank you again for kindly agreeing to be the moderator here. And so if you do have a question, Excel will bring that up for our discussion right away. So please don't hesitate along the way. Well, let's talk about a few things. I want to first say we're almost at the cusp of 30 years of success of Java. That's pretty amazing. But I'll be absolutely honest about this, and I'm shameless in admitting my fault. And if you go back and look at my presentations from maybe about 10 years ago, I was that guy on the other side of the picket line, constantly complaining about Java. And I was complaining that Java was not moving forward at the pace in which I would like for it to move. Well, all that changed for me with the introduction of Java 8. And Java 8 showed us that we can do amazing mixture, a blend of imperative style and object-oriented style and functional style of programming. Well, in all honesty, that's what got me excited in Java to begin with. Having used Java for quite a long time, I was like, yeah, what's the big deal? And Java 8 really made me revisit the language, and I started taking it very seriously. Now, of course, Java 10 gave us the ability to do local variable type inference. I call this the syntax sugar, and the reason I call it a syntax sugar is this is purely a compiler feature. There is no bytecode level feature. Colloquially, we will probably, informally say that variable is a var type. No, that's a wrong thing to say. There is no var type in Java. The type is inferred at compile time, and the compiler literally replaces the type when it compiles. So at the bytecode level, it actually has the proper type for the variable. It's an amazing feature. I could spend an entire topic on just type inference itself, but we got other things I want to focus on, so we'll move forward from there. Now, with Java itself, one of the things that excited me about Java is the transition from a statement to expression. Now, call me silly, but I get excited when I learn things about things I already know. And we all have used expressions and statements for a very long time. And by nature, statements promote mutability. Statements promote side effect. Well, when learning functional programming, I came to know that in functional programming, we favor immutability, write pure functions with no side effect. It got me thinking, wait a minute, if functional programming promotes really immutability and pure functions, then there should be fewer statements and more expressions. And so I started really thinking and rethinking about statements versus expressions. So these days, I like to program with more expressions and fewer statements. Well, switch started as a statement, but has transitioned to expression. Let's take a look at a quick example here. Let's say I want to output a grade. Well, actually, let's do it this way. So I want to say a list of, let's say, a 55, 66, 77, 88, let's say 99, and 101. And I'm going to say a dot will say a map. And in this case, I'm going to call a sample, we'll call a grade function. And then I'm going to do a for each and simply do, let's say, a system, let's say in this case, dot out, and we'll do a print line and simply print that out for a second. Well, I want to display the grade after all. So we'll start over here with a string, let's call it grade, which takes a score. And let's just take baby steps first of all. We'll simply return, something here just as a starting point. But I want to be able to work with this. Obviously, I need to call a stream on this one. So we'll go ahead and do a stream on it. So you can see in this particular case, we want to process those values. But if I were to say, for example, in here, let's say a grade is equal to, let's start with an F, and I want to eventually return, let's say, something along the lines of grade for, and I'm going to say score, and we'll say is, and we will simply output the grade. Now, this is a terrible course. Everybody got an F. You don't want that. But we want to start with really processing this. So we'll do a switch on this and say score, or maybe a math dot, let's say a min of a score divided by 10 and take a 10 itself and work with it. So in this particular case, we want to work with the value, and what are we going to see if in terms of the grade? Well, switches were a statement, and they still are, but we can do better than that. So what if I were to start with this as a 10, and I'm going to say in this case, oh, a grade is going to be an A grade. That's amazing. And we can then say maybe we can provide a few different options in here. Well, what if this were a 9 value versus maybe an 8 over here, or maybe a 7, and we could just march down this, and I think that's good enough for our purpose. And we can change this to a default in here after all, and say the score is going to be an F. And we can just remove that from there for a minute. Now, in this case, of course, we could say this is a B, this is a C, maybe this is a D. But unfortunately, though, this reminds me of a course I never took, thankfully. But I came across a professor who graded you not based on your performance in the course, but your performance in every student has had for the past 50 years. Not a great course to take, I would say. Well, in this particular case, if you will, everyone got an F, unfortunately. What a terrible thing. What went wrong? Well, that's one of the problems with statements. Statements cause mutability, but more so, switch itself is very error prone, rather still verbose, if you will. In this case, of course, we had to put that silly break after every single one of them to get the right results. Well, this is where really nicely you can see in this particular case. Of course, this should be a C to be in all fairness. We can give a C on that one. But essentially, in this case, we want to really make this a lot better. Well, let's go ahead and transform this statement into an expression. So the very first thing we're going to do here is to merge those two together and take the result of the switch and assign it to a variable. The next thing we're going to do here is to take each of these break and get rid of those, because it's an expression, not a statement, so we don't need any breaks. We'll also take that colon and transform that into a little arrow, nothing to do with lambdas, but it really says that's the path we are going to take if that label was to match. And eventually, let's get rid of that assignment operation. No more mutation for us. We can write the code more elegantly like so. And then, of course, eventually, we can make that really concise, as we can see in this particular case. So essentially, with an expression, we need to end it with a semicolon. But you can see in this case, the code is a lot more concise, less error prone as well. But not only that, we can combine the statements labels together as well, so we can maintain the dry principle. We don't have to duplicate the effort in there as well. So we saw in this case, the switch transformed from a statement to an expression. So I would encourage everybody to use expressions as much as possible rather than statements, where that really leads to a better code, in my opinion. Well, that takes us to how we can transform this further into a pattern matching syntax, and that's where the smart casting comes in. Well, smart casting basically is where, when we perform the casting, we can actually use the type immediately rather than having to do an explicit casting. So this minimizes the burden on us when we write the code. But essentially, that really is used under the hood when it comes to pattern matching as well. We'll see that a little later on. But moving to another feature I really like about is the feature of text blocks. Now, text blocks are often called as here docs in other languages. And here docs is a nice feature in a lot of languages, but I have to admit, in a lot of languages where I use here doc, it works great until it doesn't. And I cannot tell you how frustrating it is when I waste 15 minutes of my time just pleading with the syntax to say, would you please work? And it's really hard when there are idiosyncrasies in the syntax that make such a powerful feature really hard to use. I have the deepest respect for Java developers who implemented this feature because they not only implemented the feature, they thought along the lines of us, the programmers, using this feature. So let's take a look at a couple of interesting things. And this also I group under syntax sugar. And the reason is there is no text block at the bytecode level. So it purely is a compiler feature. So the compiler will take your text block and then reformat it as a regular string. And so there's no performance consequences. There's no interoperability issue when it comes to the bytecode level, when it comes to text blocks. So let's say over here, we'll call it as a greet as a function. But I want to start here by writing the function, let's say in this case, greet. And what do I want to do here? Well, I want to say a string, let's call it as a message for a minute, is equal to, and I want to return that message in the end. But then I want to say, hello there, let's call it over here, a /n, and then we'll say message plus equal to, and I would then say equal to, let's say, how are you? And I'm then also going to put a little /n. Well, put one more line on it. We'll say it is, let's say, a backslash, and I'm going to say great, a backslash again, and we will simply say in this case, great seeing you. Well, if we write this code, we can see how this was very verbose. And I would ask everyone this: would you dare to put that on your resume? Would you say I have 15 years of experience using plus equals? That's the code you will try to hide from humanity. This is not, you don't want to show this to the next generation of programmers. This is ugly, isn't it? Well, we got to do better, and thankfully we can. Enter text block. So we start with the 3 double quotes, as you can see right there. We can get rid of all that noise in the code as well. And even we can get rid of all that unnecessary escapes that we have. And we can then simply end that with the 3 double quotes in the end. Well, what's really cool about this is, and I think this is where Java sets itself apart from other languages that have similar features, and that is the indentation that you see here is considered to be a non-intentional indentation. It's an indentation for the code in terms of where it is. It's not an indentation in the text itself. I like to call it as smart indentation. So essentially in this case, if I were to go back and say replace, let's say all, and I take essentially the space that's there and replace it with a tilde just for us to see it here. And if I were to run that code, we can see there is no tilde in the beginning. And just to emphasize it a little bit more, if I were to really show the column, you can see there is no indentation at all in the beginning. On the other hand, if I were to indent it 2 spaces right there, that you can see as indentation that shows up right below the how. So that becomes what's called the essential indentation, whereas what's before that is the non-intentional indentation. That smartness really makes it a joy to really use it rather than fighting the syntax in a sense. A lot of times we're going to copy and paste this from other places. I do quite a bit of mail merge in my code. And when I want to send emails to people, which is specialized with their name and other information, but I don't want to manually create those emails, well, it becomes easy for us to be able to create those things as well. In a similar way, if you were to have spaces in the end, those spaces are automatically removed as well, unless you, of course, request for the space to be maintained, in which case it preserves it, but without it, it simply discards it as well. So a lot of naturally done features that makes it really elegant, very well thought through, which really comes back to one of the reasons why I appreciate Java. And when I'll be honest about it. When I saw lambdas being introduced in Java, I said to myself, why do I care? I can do lambdas in a lot of languages. Why do I care? And Java literally looked at me and said, here, hold my drink, and showed me what it can do. And my mind was blown because it's not just that Java gave us lambdas, but the whole idea of invoke dynamic behind the scene, which brought in the efficiency of lambda, not just for the Java language, but for the entire platform. That really caught my attention. And in all honesty, Excel, today, when I look at any feature, I go behind the scenes and look at what Java does beyond the surfacial things we normally see. And every single time I go investigating a little further, Java seems to surprise me pleasantly about how well Java takes features that are known in other languages, but does it very differently for the better use and benefits of the programmers on the platform. So features are not thrown at us. Features are implemented in a way we can benefit from them to the fullest extent from different angles, in ease of use, in being less error prone, where it is actually performant and it's easier to evolve, and also the interplay of the features as well. That's what really, excites me about Java is not that Java has these features. When somebody comes to me and says, why do I care? I can do this in other languages. I'm like, yes, you can, but not the same way as you do here. You got to look behind the surface to really start understanding and appreciating those benefits. Well, the next thing I want to emphasize here is two features that actually interplay with the pattern matching in a really nice way. And we can talk about that as well. But if there are any questions along the way, I definitely want to interact as well. So if there are any questions related to what we talked about so far, don't hesitate to bring that up as well.
We don't have questions directly on the features that you have presented so far. We have people already commented in the next features that you're going to present. And well, my only comment to you is that what you have presented, it creates a more clear code. And Marie also agreed that reading code, it's extremely important for developers. So anything that keep us in a more concise, expressive, I'm with you. That's are the things that make me really happy of using for example, the switch or the text blocks. But as I will post any questions that come your way.
Yeah, and I would say Merit is the queen of reading code in my opinion. So definitely listen to her. When she appreciates the code is more readable, then I buy it. Absolutely, I couldn't agree more on that. Absolutely. But having said that, what records intrigue me is essentially the nature of records. Really is not just about removing boilerplated code. That's not the main purpose in this case. For example, if I were to say in this particular case, if I were to say, let's say a record location, and I'm going to say double lat and double lon, Well, this is an amazingly concise syntax. So again, looking at the syntax, this is one of the things that I've been really thinking about. To me, programming languages is syntax is what you look at. Semantics is what you should see. So this is to me one of the lessons I've really learned over time. Syntax is what you look at, but the semantics is what you want to see, because the semantics is often hidden behind the syntax. You can learn the syntax by looking at it, but you have to learn the syntax by digging deeper into it. That is the fun part of it. So in this case, of course, I can say, if I were to define a location, one equal to new location, let's say an 84.23 and 123 point, whatever number, and I want to output the location one in this particular case. Well, here's the charm. Not only is the syntax concise, we all like this BOGO, right? Buy one, get one free offer. So a BOGO is always good. Well, Java is greater than BOGO. Java offers buy one, get five free offer. That's even better. You don't get one thing free, you get five things free. How cool that is, right? So you got the constructor available. You also have a getter available for the components or the properties, if you will. You can also look for, essentially in this case, the equals method and the hash code method. But not only that, you got a nice little two-string method which you can override if you want to, but you can see the output which is sensible in terms of displaying the lat and lon. But not only is that exciting, but really what's exciting about records is the components or the properties of records are immutable by nature as well. So you can output, in this case, a location, let's say one dot, in this case, we'll say a lat, and you can see the lat being displayed. But what if I want to take the location one and modify the lat to maybe some other value? Well, that's not allowed. It's immutable. You cannot modify it. So which is another thing that it promotes that immutability really nicely when it comes to the records as well. There are a few complexities associated with the records, unfortunately, though, but ignoring those for a minute, it definitely is a very exciting feature. But record itself is useful, but interplaying records with really the concept of using pattern matching with the destructuring is even more powerful. But Java is not done with records at this time. If you're used to languages like C sharp, in C sharp, you have data classes where you can take a data class and you can do a with and provide a newer value for a property. And because it's immutable, it'll create a new record or a data class with the updated property value in it. Well, Java is really going in that direction as well, with a with or withers, as they would be called, and you can build this particular record, and you can evolve the properties as well. It will give you this kind of a feel of a builder, but essentially the intention is not a builder. The intention is to really evolve and update properties as you may go by. That becomes very powerful set of operations as well. So essentially in this particular case, that's a record that you can benefit from, but that also is very powerful when combined with a sealed class. So what in the world is the purpose of a sealed? I'll give you an example of this where a sealed can be really beneficial. I have a client who had has a problem where they built a very powerful, comprehensive product, but the people who are using their product, their clients, can build plugins for that product. Well, when they build plugins for their products, they want to allow the plugin implementers to use certain interfaces, but they don't want them to implement those interfaces. Well, we know this. If you have a class And if you don't want anyone to extend from that class, you can make the class final. But you cannot make an interface final after all, because if you make an interface final, no one can extend from that interface. That interface is useless. Well, so how do you tell you want your team to implement that interface, but you don't want anybody external to implement that interface? Well, this particular company that I'm referring to had to implement this logic with an enormous amount of code. You can imagine not only the effort to write that code, but the effort to maintain that code as well as time goes on. Well, that's really where a beautiful feature of sealed really comes in. So you can say, for example, an interface called trade, if you will. So this interface trade, well, it doesn't do a whole lot right now. And then I want to say in this particular case, you can essentially say you have a sealed, and you could even create a record if you really wanted to. Well, guess what? Records are final as they are. So if you were to create a sealed class, you may have to mark them final. Well, with records, you don't have to because they're final already. So you can say a cell in this case, and you could say this is the ticker you want to sell and the quantity you want to sell as well. Likewise, you could say a buy as a record as well. So in this case, we are saying we want to create an interface trade, but we are going to extend that interface. In this case, we can say extends, or in this case, of course, because it's an interface, implements trade. And you can similarly say that you are implementing the trade interface here as well. So this really gives us the ability to create the sealed hierarchy. And I want to simply say over here that we can provide these two in here in terms of the records. So essentially, you want to be, oh, let's see what this is complaining about. So it says a class error record is expected in this particular case. On line number 4, it's not too happy with me. Let's see what's going on. So sealed record cell, and I want to say this is going to be implementing the string and the quantity, implements trade, which is the interface. So I'm not exactly sure why that's complaining. I'm probably doing something absolutely silly and not seeing what I'm doing here. Anyway, we'll see if we can figure it out and see what's going on. I'm going to say in this case, let's go ahead and say, let's for a minute, let's just get rid of the sealed for a second, and then we'll get rid of the class and make it a class for a second as well. We'll get to more details one step at a time. So I'm going to implement the sealed right there for a minute. This is going to be a class after all to get started. Let's do this. So essentially, we have a little class that we are implementing. Well, but a cell is going to be a record, we said. So I'm going to call this one as, oh, I know why, never mind. As you can see, I sleep at the wheel, and sometimes that's not a bad thing. I put the sealed in the wrong place. That's why. Just a background thread takes time to process it. The sealed has to be the interface, not the class over here. Okay, there we go. All right, so sealed interface, that's what we wanted to create. There we go. Finally, my background thread caught up to the code error I was making. So right there is the record. We don't have to mark it final after all, because this is going to be a final class already. Got it. So essentially, we have the sealed hierarchy we built in. But why care about this? Well, here's the reason for it. This is a very simplified or a default form, but in general, though, we are going to say in this particular case, this is going to be permits, and we can permit a sell, and we can permit a buy. So this is one of the ways in which you can restrict the members that you are going to allow for this particular hierarchy. So as a result, if I were to say, in this case, let's say hedge is going to be a kind of trade I want to perform, well, that will not be allowed because it's not in the permits hierarchy. So that is one of the nice things about sealed. But why is sealed really exciting? Well, it allows you to build a hierarchy where you can tell who can use your interfaces and who can extend your interfaces So it gives you that clarity as to how you control your hierarchy. But to me, one of the exciting features of sealed is, once again, just like records. They both, records and sealed, are nice in their own, but the way they interplay with pattern matching is what is most exciting for me. And I want to bring that up next, but I want to entertain. Yeah, please
Yes,
do.
we
Yeah,
do have questions, and I will show you. Well, you already answer this one. I don't get what could you mind if someone wants to implement one of your interfaces, but you already said like it's for restricting. But if you want to add more to that,
yeah. So let me give you an example of this. The reason why you want to do this is, let's take an example of a trade, for example, right? So a trade is an interface, but your system may only allow a certain types of trades. That's only you can possibly do. Legally, maybe there is a requirement that a trade has to be one of these three kinds, four kinds. I can use trades in my plugin, but I should not be allowed to invent my own trade, right? So this really is, so to answer the question, and thanks for that question, this really becomes domain specific. In certain regulated industries, there is a requirement as to what these entities of abstraction can be, and we are allowed to use those abstractions, but we're not allowed to extend those abstractions. So this really is more domain specific. In a normal application, we may not bother to make those enforcements or constraints. But in certain applications, this can be really dangerous. If you receive an object of an interface, that's not one among the things you are expecting, either that could lead to errors in your code or to be defensive. You got to write a lot of code to weed that out. That is expensive coding to make it error proof. Well, if the compiler were to guarantee that, that eases the burden on you. That's the reason for really doing that.
we have another question on records. Is there any builder?
So the key is, my personal opinion is that builder is overrated. I was pairing up with a team a couple of months ago, and I looked at this humongous builder code, and I wanted to be polite, and they're really nice people. And I looked at it a few times, and then they looked at me and said, "Something is bothering you here." And I said, "Yes, it is." And they said, "What is it?" And I said, I didn't use words. I said, "Would you mind if we refactor this code just a little bit?" And they're like, "Sure, go ahead." And we refactored the code, and that much line of code became that much code. And they looked at it and said, "Gosh, this is easy to understand. This is simple to work with." I said, "Yeah, that's why I wanted to refactor it." And then one other person looked at me and said, "I know what you did there. You got rid of the builder." And I didn't want to, argue about it. And I kind of looked at the person and said, "Looks like it." And then he said, "Yeah, I didn't understand why we did that in the first place. Because the person who wrote it was so interested in builder, and so we kept it when they wrote it, but I couldn't really understand why we did that also. But now that you refactored it, I'm convinced that we don't need the builder here." I've seen so many cases where I truly believe the builder is overrated. There are some situations where builders are useful, but a lot of times they are not. In the case of records, the withers really are providing the builder like cascading, but the intention is not really the builder. The intention is to be able to take an existing immutable object, but more concisely create a copy of it with certain components in it updated. I think that's a much better use case than a builder use case. That is, again, my personal opinion. I don't generally follow patterns because it's a pattern. I want my code to be elegant, concise, and meaningful. And if it so happens a pattern is useful in doing so, I'm good with it. But if a pattern is not making my code concise and elegant, with respect, I would send the pattern away and then code without it. And Builder is one of those I found to be, you may be surprised to hear, but the least useful in at least most of the code I've written over time.
Well, I agree with you, Venkat. It is an important, well, it is a tool and we need to learn where to use it, where the pattern actually matches, where we will get the most benefit, not just use it because it is available.
That's
We
right.
have another question regarding the memory efficient as a C structure, if it's a record.
So is a record as memory efficient as C structure? Is that the question?
Yes.
I don't know the answer for that. Only because I've not really compared the two to see if it's memory efficient. I would let me put it this way. A record is no different from a class. So the question you want to really ask is a Java class as memory efficient as a C structure? If the answer there was yes, then the answer here is yes. So that's the way I would relate to it, right? It's not a topic I've spent a lot of time thinking about, but I can tell you what a record is. A record is not a separate new thing. A record at the end of the day is just a final class with no setters and everything else marked final. So a record is a class. So your question can be translated to, is a class memory efficient like a structure in C is? And I will let you take that further from that question.
Well, thank you very much, Venkat. We have more questions, but I think they are going to be much, much better at the end.
All right, sounds good. So let's talk a little bit here about one of the favorite features where these things nicely interplay, which is the pattern matching. So in a way, if you think about it, uh, in the Cruising Along with Java book, when I was writing it, I wanted to come up with a metaphor, with the analogy as to how you probably know this, Excel, being a good friend, but I get excited too easily, right? So when I get excited, I want to throw in an analogy to how I feel about it. And the analogy I was able to come up with when I was writing the book is, remember the movie when Captain America is being introduced. Well, here is this kid who is skinny, couldn't compete being in the army, is getting rejected over and over, and then gets transformed into the superhero of being Captain America. Well, okay, maybe I'm getting overly excited about this, but I look at the switch statement as that puny little skinny, not so great, don't want to be friends with kind of a kid, and then the switch blossom into this Captain America superhero, if you will. That's the transformation of the switch statement to a switch expression to a pattern matching syntax, if you will. That's kind of the excitement I have in terms of how this has evolved over time. So in this case, let's say for a minute, I want to go ahead and say, call a process function. And in this case, I want to send let's say, let's say we'll send a cell, and we'll say a new cell. And in this case, we'll say we want to sell Goog. And let's say about 100 of those we want to sell. Well, likewise, we will do maybe a buy as well. And in this case, we will say that we are interested in buying. We'll just throw in an AMZN here, and we'll say 200 of those. Well, let's take a look at how this is going to look like. So we can say in this case, we can provide a process function. And in the process function, we can say take a trade as an argument. And then, of course, within this, we can specify what we want to do about trading. But I want to just pause for a minute and take a slight detour before we come back into it. And this is one of the things I think where we can get a little agitated if we look at things as yes or no, good or bad, right or wrong. But I tend to really take a view of where things can work together rather than working instead of each other. So we all have benefited clearly from object-oriented programming. I don't think there's an argument in my mind whether object-oriented programming is the right thing to do or not. It is the right thing to do in a lot of situations, but it's not the right thing to do all the time. And as it turns out, if I have a class hierarchy, and if I'm the maintainer of the class hierarchy, I can benefit from polymorphism, which is awesome. And you can call a method using the base reference. The appropriate method is executed on the derived type. Bingo, we got extensibility. But imagine for a minute that your class hierarchy is from a third party. You didn't write the hierarchy, but the hierarchy is from a third party library. You need to use different classes from that library on your side. How do you do that? Well, if you want polymorphism, you will have to implement your hierarchy, which is parallel to their hierarchy. And based on what the type is, you will do implementations in your hierarchy. Once you finish that, if you still have the strength to stay awake and still be able to think, you might say, ooh, that is like a visitor pattern. I will, with all respect, challenge everyone here. When was the last time you implemented the visitor pattern and felt like this was the most awesome thing and the right thing to do? Well, it's one of those patterns I shy away from most of the time because it is complex. It is so much more bloated code you wrote just so you could exercise polymorphism on your side of the hierarchy. When polymorphism and OOP work really well, that's fantastic. When it doesn't, what could you do? This is where you can mix and match OOP with data-oriented programming. So I'm not suggesting we do data-oriented programming instead of OOP. I'm suggesting let's put them together. So it becomes really useful to do OOP with the data-oriented programming because I think that is a nice combination. Without it, without pattern matching, we'd be doing a lot of if-else statements. That becomes really smelly. And oftentimes people say, aha, if you do polymorphism, you don't have to do this if and else. I totally agree. Because if you look at two ugly, I totally agree. If you look at the two ugliness, we're not choosing which one is a better solution. We're choosing which one is least really, right? Which one is least ugly is what you're asking. So you're not asking which is the best. You're asking which is the least ugly, unfortunately. But I think we can do better. And that's where, coming back from the detour, I think this is where pattern matching really can shine, if you will. So essentially, in this case, we can say return switch. And in this case, we can provide the trade. And we can then say a case of a cell. And we can then do whatever we want to do for the cell. Well, looking at this here, the cell here is essentially using a pattern matching with instance of what I like to call a smart casting, if you will. So as a result in here, I'm going to simply return selling. Let's say we can then specify the cell dot, let's say the ticker like so, and then maybe we can say quantity, and then we can simply specify the cell dot quantity as well. Likewise, we can say a case in here, we could specify a buy, and we can say buying, and I'm going to simply say buy dot ticker as well, and we can return that information. But notice we didn't use a default here. Why? Because the reason really is we don't have to, because it's a sealed hierarchy. That's the benefit of sealed that comes in here as well. But just to emphasize that interplay we talked about, while this code works, it's a little verbose. After all, we want the ticker and the quantity. So why bother with all that noise? So we can simply say this is a string ticker, or if you know me already, I'm going to put a var and not a string. And then I'm going to simply say int quantity or a queue. And just to emphasize, the name can be different. And then you can simply replace that with the queue like so. And you can use the type destructuring of the records along with the pattern matching as well. Likewise here, we could say a var ticker and an int quantity, if you will, and then we can simply replace this with a ticker as well. Or you say, wait a second, but I'm not using quantity after all. Why in the world am I using it? Well, this is where there is an international, you could say, national symbol for I don't care. And that is called an underscore. So you can nicely use an underscore right in there as well to emphasize that you are ignoring it with intention. So you can simply use that underscore. What is really cool about this underscore is that it allows us to use sensible variable names when we need the variables, and to not use any variable name at all when we don't need it. As an example, now that we are approaching the good holiday season, why not simply try this one here? We can say in this case, we can create a list of, let's say, 1, 2, 3, and we'll say a for each. And I want to print out, after all, some value, but what could I provide over here? Well, I don't care because I'm not going to use it. So I'm going to use an underscore and simply output right in there, if you will. So we can simply say output, if my fingers can type the output right there. There we go. And I'm going to simply say in here, hey, how about a nice message for the holidays? And we'll simply say a little ho as well for that. So essentially, you can use an underscore when you truly do not care to use that particular variable in these different contexts as well. So essentially, this gives us a nice way to intermix certain features, but also go towards more conciseness, and also elegant and maintainable code is another thing that I really like about it. Well, we'll take some more questions in a couple of minutes, but we talked about destructuring on unnamed variables. But one of the biggest features in there is, of course, the concept of asynchronous programming. It is a topic that's absolutely fascinating to me. I've been watching this for the past nearly a decade as it was evolving in Java, an absolutely fabulous feature. And I think one of the things is, functional programming in Java 8 made programmers more effective. Virtual threads will make production environments more effective. And that is what I like about this, is it's a true feature that has an impact on scalability with very little effort on our part to really write the code as well. So in terms of where Java is heading, I'm absolutely excited about where Java is heading. One of the things I respect about Java is they're not sitting there and desperately asking the question, what should we change? It's quite the opposite. There are a mature set of people thoroughly evaluating the benefits of features that can be brought in the language, with emphasis on three different things. A, is this feature really feasible? If something is not feasible within a reasonable effort, then they're not going to be implementing it. The second thing is, truly they're asking the question, is this truly useful for Java programmers? Just because something is flashy out there doesn't mean we need to bring that over. It got to be truly useful for the Java community. And the third thing they're asking is, if we implement this feature, what's going to get harder in the future? That is a much more difficult question to answer, because we can be infatuated about something and implement it quickly and then say, oops, we cannot do these more important things later because we implemented this, and going back deprecating things. because we realized what we did was great at the time, but we didn't think through, is simply not the Java way of evolving a very powerful platform. That's what I feel really is the core of how Java evolves. Is Java evolves responsibly and in a mature manner, not in a half-assed, let's throw things together because people want something in here, let's make them happy. They're not interested in making us happy. They are interested in building a solid language that is sensible and also concise and useful and less error prone, and so on. So it definitely is power packed. And the future is truly looking good, in my opinion, with a lot of exciting things happening. I very rarely talk about future features in general, but I know there's a lot of features being discussed. And as they emerge, I would be delighted to use them. One of my goals, and there's not a whole lot of time, so they better get acting pretty quickly, is before I retire, I want to at least use value types and generics with value types at least once. And my retirement is not far. So before I retire, I want them to implement it so I can use that and call it done. And I'll throw in my towel on that day, maybe. So that's a feature I'm really looking forward to. But I want to see if there are any questions or comments for the next about 3+ minutes that we have left, if there's anything we want to cover before we call this one done.
There are so many questions. Well, not so many questions, but one of the things, a shout out for all the people that are making the comments so lively. And thank you, Marie. Thank you, Johan. Thank you. I saw Tom, and they are actually answer some questions that I didn't even post to you. On the terms of you retiring, I don't think you will do retirement so soon, Venkat. You are so active and we need you in the community. So no, not talking about that one. So let me see. There are some general questions that they were asked at the beginning, but I think it's really interesting. For example, how, like, do you have any suggestion into migrating, for example, from Java 8 hopefully to 24 next year? But the our this person is already thinking, Kumar is already thinking even in the future.
You bet, absolutely. And that is the real right way to do it. I often tell people, if you are going to migrate all the way to the recent version. Don't migrate one LTS to the next, to the next, to the next, unless you like really having pain several times over, right? So that's the only time to really say, I like pain, so bring it on 3-4 times over. So yeah, migrate as soon as you can. One of the things you may want to even consider is to maybe this is where relying upon AI-based tools and tools that can help you to modernize your Java code. Uh, it the journey is easier if we have a fairly good amount of automated test. I'm not using the word unit test. I want some kind of a feedback. So if you have some kind of a automated test, that's awesome. If you don't have automated test, at least some set of really thorough manual tests to get the feedback that everything is working. Then I would say use tools to automate it. Well, what if you don't have an ability to use the tools for whatever reason? My general recommendation is start really upgrading only parts of the code that you're actively modifying, whether you're fixing bugs or you're refactoring to come back and add more features into it. I'll be absolutely clear about it. As much as I love all these features, I will never recommend somebody to just go spend time taking existing code and keep converting it. Sorry, we have time which is limited. Use the time wisely. So if you're modifying a piece of code because you got a bug to fix or enhancements to make, then at that time, refactor that portion for using modern features. Don't go on a witch hunt to modify everything because you feel like it's got to be upgraded. That's not a good use of our time. It's important to be pragmatic and prudent about our use of time as well.
And Venkat, you saying that that's the strength for me of Java. Java as the as a platform, because as you mentioned, how they developing the language forward is very thoughtful. So we have the ability to say whatever we are developing right now, it's going to be running for the foreseeable future, and that peace of mind and the knowledge that the Java team is trying to improve the performance, even if you don't adopt new APIs or if you don't adopt the new features, there are going to be improvement. That's one of the reasons why I'm so happy to be a Java developer. But there's and you are a polyglot programmer, and we love that about you. And I'm not the only one that have seen so many of your sessions where we also encourage people to be polyglot, because we need to learn the weakness and the strengths of many programming languages. And like that, Venkat, there is tons of messages about thinking about back about your other sessions and other presentation and suggestions. So I just want to thank you so much, Venkat, for being here, for giving us 1 hour of your time. I think it was very enlightening. And thank you very much for the audience. You made the comment section so live. And yes, thank you, Kim, for having us here.
Well, I want to say thank you as well. And you made this so easy, Ikshal. I really want to thank you for being so lively and interactive. I couldn't have done this without your support. So thank you. And thanks to Kim and the rest of the group for making this happen. Of course, none of this would matter if we didn't have eager developers who are interested in learning. And that's one of the things I love about the Java community is it's the community behind Java, and we are part of that system as much as the people developing the language as well. So thanks for being as part of this community and making these things happen. I really appreciate it. Thank you.
Yeah, couldn't have said it better. And thank you both so much. And thank you to everybody who joined today. Thanks for all the questions. If you didn't get your question answered, please do pop it in the Slack and we'll try our best to get them answered over there by the rest of the community, as well as Venkat and Ikshal. And if you want to see more of these, please join us over on Meetup. We try and run at least one a month and hopefully more starting next year. And if you do want to get involved, do a talk, or your company would be interested in sponsoring or giving away a gift, you can find me, Kim Fletcher, on Slack, and let's chat over there. But again, thank you all so much for being here today, and we will see you all soon. Take care.